10 a.m. The default C++ standard depends on the compiler and its version. It is no universal default mandated. Newer GCC versions, they take C++ 17 as a default. You can check it here. Okay, it is C++ 2049. It's C++ 20. No. What the hell? It is C++ 14, kind of old. So test is the name of the executable, not a directory. After compilation, if you do this, so yes, you will see something like this, and this is a binary generated. What are object files? If you compile with -c, you will get this. This is the object file. It contains machine code but is not linked into a runnable code. Creates an executable test. Typical. So this test.cpp with will compile into test.o, will link and make test, which is the executable. So if you do this, which is let me show. If you do this, and if you do this, so if you see, this is the object file. Although it is also binary, but yes, this is the object file. But if you see this is also an object file. This is binary object file. If you do this, it doesn't work. But if you do this, it works. During compilation, all the everything is converted to symbols. Not exactly. So you have this, include are expanded, macros are substituted. Output is still C++ source code. So this is pre-processing. Okay, so C++ your source first goes through pre-processing, then goes into compilation. The compiler parses the C++ code, converts it into assembly. For example, this. At this stage, variable functions are represented internally by the compiler, translated into machine instructions. The assembler converts assembly into machine code, produces an object file. This object file contains machine instructions, data section, symbol, table, relocation information. What are symbols? Symbols is a name associated with an address or entity. For example, these are the symbols. Linkin, linker, and then linker. These all symbols. So the file contains machine code, data, symbol table entries, relocation records, and all of this. Okay. Nice. One second. Okay, guys. Oh, there is something wrong with my stand. Let me fix it. Yeah, I have all this. OS fundamentals. What we are going to study today? OS fundamentals. We are going to study networking today. We are going to study okay. So I am planning to revise now in the sequence. So I'm planning to revise. First, I'm planning to revise OOPS. Then I'm planning to revise some concepts of like C because C is different from C++. I still have a lot of idea about C++, but not C. Then important interview related questions to C++ or C, like the language related questions. I need to practice that. Then I have to prepare for design principles, like solid principles and all the good design principles. I forgot them long time. The common design patterns. I need to revise that. Then I also need to revise in this design principles. Tell me about all the good coding principles, solid, dry, etc. Then I have to revise Linux commands. Although I've used them a lot, but like just a revision, just doing it at once. But I have like experience working on it. Then I have to revise all the OS fundamentals, process, loop, semaphores, and all of that. And then I need to revise network stuff. So all of these are super important, and I think resume and all of that I know. So I will start with the sequence. Let's start with oops first, or I'll tell you. But what do you think? Like, is this good enough? Because C++ I'm quite comfortable with, so I think I don't need revision there. Software for open networking in cloud. It's not a. Okay, so let's start with oops revision first. Tell me everything because also tell me like general context. Let's start with oops. And then after revising all the concepts, also tell me like 20 top interview questions also related to oops, where people get stuck. Also remember that there was one thing that there is a table because like different functions they are overridden and all. So there is a linker table, there is a dining table. I forgot the name of that. So all those things also you tell everything. Like that is an important one. I forgot the name of that table. Okay, guys. So I am back. Let's do the revision. Hey, these interview questions, can you also give me answer like now? Next, give me top 20 interview questions related to oops with a detailed answer. Okay, now give me that. V pointer. The name of that table was VT table. Good. Okay, so guys, let's start. Four pillars of OOPS, which is capsule, encapsulation, abstraction, inheritance, polymorphism. Encapsulation is abstracting all your data with access modifiers and methods and controlling access and bundling the data together and methods together. So you have your bank account, everything is private by default. You can also make some public. This is helpful for data security, protection, controlled access, streamlining access, better maintainability. Why make variables private? So that the direct manipulation and enforce variance through controlled interfaces. Abstraction means showing only the necessary details to the client and hiding the complex implementation. So if the user does shape or draw without knowing the implementation. This can be done with abstract interfaces. Inheritance. Acquire properties of another class. So you have a base class and then you have derived class. Polymorphism, same inherit interface, different behavior. So you have this, it calls dog implementation, two-type compile time function overloading and operator overloading also. Runtime behavior, virtual functions resolved at runtime. Function overloading versus overriding. Overriding means same class, but the function signature is different. This some functions name is also same. The parameters are different. The data types are different. The count is different. Overriding means happens through inheritance. Signature is same. Derived class redefines a base implementation. Uh, Runtime polymorphism. Virtual functions, most important. So this is a virtual function, and output is derived and all of that. This is probably what you were remembering, not the linked. It is virtual table, V table, generate compiler generated. Both pure virtual functions are used to achieve runtime polymorphism, but they serve different purposes. Virtual function is a member function in a base class that can be overridden in a derived class, but it already has a definition in the base class. Key points declared using virtual keyword has a body or implementation in the base class. Overriding the derived class is optional. It is declared using virtual keyword, has a body implementing. This is function shadowing. Has a body implementation in the base class. Overriding in the derived class is optional. Allows time and name binary decided at the runtime. Pure virtual means that has no implementation in the class must be overridden by the derived class declared using is equal to 0. No implementation in the base class makes a class abstract. Cannot instantiate the base class. Derived class must override it. Virtual functions. V table is probably what you're remembering, not link. It is compiler generated table, virtual table or V table, stores the addresses of virtual functions. For example, it is this. So conceptually, F1 will be at 0 and F2 will be at 1. Memory. Memory storage landscape. Compiler generated table stores addresses of virtual functions. For example, this F1 is at 0 index, F2 is at 0. The virtual table or V table is a mechanism most C++ compilers use internally to implement runtime polymorphism for virtual functions. So what you need a V table. For example, you have a base class which has a virtual function. The derived class is overridden the virtual function. And whenever you call that function on the PTR, which is base, on the base class, at the compile time, tells the compiler that PTR is a base class. And at runtime, PTR is new derived, which is derived class pointer. So it actually points to its derived object. The question is, when we write PTR show, how does a program know whether to call the base class show or derived class show? This is called V table. V table. For every class containing at least one virtual function, the compiler creates a hidden table which is called V table. For example, the base class, which is void show, compiler creates something like base show, base print. For this, it creates derived table, base V table, derived V table, derived V table, derived show, derived this. V print. Each object of a polymorphism class contains a hidden pointer called V virtual pointer. Derived pointer has a derived VPTR and the members VPTR points to the derived table. The VPTR is a pointer to the derived to the V table. It is automatically initialized by the consumer. Now, when this happens, PTR points to derived object. They go to the VPTR. From the compile generates code relevant to this. VPTR points to derived V table. And from there, the derived show is executed. This is called dynamic dispatch or late binding. Memory layout. So you have VPTR pointer is 8 byte into 4 byte, which is size of base. What happens without virtual? Compiler decides at compile time using the type no V table is involved. Interview question: does every object have a V table? No. Each class has one V table. Each object has one VPTR pointing to the class's V table. Does a class get a V table if it has a virtual function? Yes. If even one virtual function is enough, does a pure virtual function create a V table? Yes. Abstract classes also have V tables. V table and VPTR. If V table part of C++ standards, no. The C++ standard specifies the behavior of the virtual function. It does not mandate V tables. However, almost all major compilers implement virtual functions using V tables. Cost of virtual function is this, which is one extra pointer, which is 8 byte, which is 64-bit on a 64-bit system. A V table is a compiler generated table containing addresses of virtual functions. Every object of a polymorphic class contains a hidden VPTR pointing to the appropriate V table, enabling runtime polymorphism and dynamic discharge of virtual functions. Okay, guys. VPTR is virtual pointer. V table is a table. VPTR points to the table. It is a pointer of 8 bytes for a 64-bit system, obviously, which is stored on the object. Pure virtual function. So you have which has no implementation, which is equal to 0. There's a use of pure virtual function. You don't want to implement it in the base class. You will not be able to instantiate the base class, but you will always have to override it in the direct class. Abstract class, which contains at least one pure virtual function. Interface. C++ does not have explicit interface, but interface by that you can mean that it does not have any data type. So it does not have any data members, and all the methods are pure virtual. Virtual destructor, extremely important. Can you also tell me more about virtual destructor? Virtual destructor are one of the most commonly asked C++ interview questions because they're directly related to polymorphism and memory management. Initialization, please. Why do we need virtual destructor? So suppose we have this. The base class destructor is virtual. So the derived class will have to inherit it. For example, now the base is called first, and then the destructor. Note something like this. Derived destructor was never called. If the derived class owns the resource, then delete pointer will not release ARR, virtual destructor. In a normal destructor, it is not called. If we call a virtual destructor, it is called. What happens? Just like virtual functions, destructor entry is also stored in the V table. If it is not virtual, when this is executed, runtime checks objects VPTR, finds actual type is derived, calls this, the automatically calls base. Destructor, call order. Constructor, construction, derived D. Order, base and then derived. Destructor, derived and then base. Reverse order of construction. Destructor call order is opposite of constructor call order. So constructor, your first base class constructor is called and then derived class constructor is called. But a destructor, this is very, very important. Oh my god, this is so important. The order of constructor and destructor is opposite. So if you have inheritance, if you have a constructor and first always your base class constructor is called and then your derived class constructor is called. But if you call it destructor always, because it will function overriding shadowing if you don't do virtual destructor. So then only base class destructor will be called. But if you've done virtual, even then your derived class destructor will be called first and then your base class destructor will be called. This is reverse order of instruction. If a class has any virtual function, its destructor should almost always be virtual. This is considered a good sign. Many people don't know this. A destructor can also be pure virtual, but unlike other pure virtual functions, you must also still provide a definition. Why? Because every derived object eventually calls a base destructor. Without a definition, that linker would fail. Oh, this is so important. Can constructors be virtual? No, not allowed. To call a virtual function, object must already exist and have a valid VPTR. During construction, the object is still being created. Yes, in fact, polymorphic base classes, they almost always have virtual destructor. Can a destructor be pure virtual? Yes, you can keep it. What if I forget to make the destructor virtual? Only the base destructor executes. This can cause resource leak, memory leak, undefined behavior. Is there any cost? Yes, the class becomes polymorphic, gets one weak PTR per object, one destructor entry in the weak PTR. So there is an overhead which is negligible compared to the safety it provides. I still didn't understand why constructor can't be virtual. Virtual functions require an already constructed object, but a constructor is responsible for creating that object in the first place. How virtual function works? So you have a virtual function. When you do this, the compiler VPTR object VPTR VTable derived. Now notice something different. When object must already exist because we need this VPTR. Without an object, there is no VPTR. What happens during construction? Construction happens when we allocate memory, construct base part, construct derived part, object fully ready. The derived portion does not even exist. Suppose constructor were virtual. Then how does compiler know which constructor to call? We don't know. VPTR has not been created yet. It's like chicken and egg problem. Virtual dispatch requires object exists, constructor requires object exists. So this is chicken egg problem. Constructors cannot be virtual because the virtual dispatch requires a fully constructed object and a valid VPTR. During object creation, the object does not yet exist, so there's no VPTR, and therefore he cannot determine a late binding of the constructor, which one should be called. This creates a circular dependency, making virtual construction impossible. Object slicing. Object slicing is very important concept. Object slicing happens when derived class is copied into a base class object value by value. The derived class gets sliced off and only the base portion remains, for example, here. So now derived D, base B is equal to T. Derived class had X and Y, but after this, B only stored X. V part is lost. The loss of derived information is called object slicing. Why does it happen? Because base B allocates memory for base members, there is simply no place for derived members. Copying derived into base means the base option is copied, and therefore this happens. Because when a derived object is copied into a base object and the derived specific information behavior is deleted and discarded, leaving only the base portion. This is why polymorphic objects should generally be passed and stored using pointers or references rather than values. So you can even after that you don't lose the data. Upcasting means converting a derived class to a base class. This is upcasting. This is perfectly safe. Upcasting converts a derived object to a base class or a reference is always safe because derived contains the base subobject, but downcasting is should have dynamic cast because the runtime may not have. Upcasting causes object slicing. No. diamond problem. D inherits this. We have virtual inheritance. Diamond problem is one of the most famous multiple inheritance issues in C++. So you have this class B and A, and then this looks like diamond. What goes wrong? Compiler ambiguous. The diamond problem occurs in multiple inheritance, wherein class inherits from two classes that both inherit from the same base class, resulting in duplicate copies of base class. It is solved using virtual inheritance, where intermediate classes inherit a common base class virtually, ensuring that only the shared instance of the class exists in most derived object. Prefer composition over and more where inheritance. Inheritance models is a relationship. So animal is a dog is an animal. Benefits of inheritance: code reuse, runtime polymorphism. Uh, Problems with inheritance: there is tight coding. Car is an engine, which is wrong. Fragile base class. Many derived classes depend on it. Changing base class may unexpectedly break them. Deep hierarchy is very difficult to evolve over time. Composition means it has a relationship. So car has an engine. So this is loose coupling. Loose coupling. Car does not depend on engine's inheritance directly. It simply uses engine. Better flexibility, easier testing. Bad design, good design. When to use inheritance? Use inheritance when true is a relationship exists. Need runtime polymorphism. Uh, the relationship is static. It is not going to change. Like it is all, the directness one going to directly depend on the base class implementation. But if it is anyhow flexible, if there are changing customer requirements, you always should go for virtual class. Sorry, composition. You want flexibility, you want loose coupling, you must go for that. Static members are shared across all the objects, only one copy. Friend class can access private members. Break encapsulation. What is difference between abstraction and encapsulation? So in abstraction, you hide the implementation, complex implementation from the client side, but in encapsulation, you bundle the data with access modifiers. Encapsulation is about bundling the data and restricting direct access. This is for security and protection of the data and for streamlined controlled access. But abstraction is about hiding the implementation detail and exposing only the required functionality. So it hides the data and it hides complexity. What is the difference between overloading and overriding? Overloading is the same function name, different parameter list. But overriding means derived class provides its own implementation and runtime polymorphism. Polymorphism means one interface with multiple implementations depending on the actual object. Different implementations execute. What is runtime polymorphism? Runtime polymorphism happens through virtual functions. The decision about which function to call at the runtime. How do virtual functions work internally? They work with vtable and vptr. Vtable is with respect to one class, but vptr is the pointer to that vtable, which is owned by every object, which is created during constructor. Each object has a VPTR, points to the class vtable. Vtable stores the address of all the virtual functions. And this is executed. This is also called late binding because we figure out what is vtable. Vtable means virtual table. It is compiler generated. It stores addresses of virtual functions conceptually. VPTR means virtual pointer. Each object with virtual pointer contains a hidden pointer. It points to the corresponding V table. Without V table, runtime polymorphism does not work. Object slicing: whenever your derived class is linked back to your base class, the additional derived object related members, they are sliced off because the base class doesn't have it. So always use pointers for dynamic and typecasting, and never values or references because they will be deleted. Why should a base class destructor be virtual? Obviously, because the destructor call order is opposite of constructor call order. So always, if you are doing, if your class base class is polymorphic, means you have overridden virtual functions in a derived class. Always make the base class destructor as virtual. Can constructors be virtual? No. The object must be created before virtual dispatch can occur. V-table setup itself happens during construction, therefore constructors cannot be virtual. Can static functions be virtual? No. Static functions belong to the class. Virtual functions work through objects. Since static functions, they have no object, virtual dispatch is impossible. What is pure virtual function? It has no definition, it has no implementation. Derived classes must implement it, otherwise it forms an abstract class. A class containing one or more pure virtual functions is an abstract class. What is the difference between abstract class? Abstract class has data members and some virtual, pure virtual, whatever methods, but an interface has every method is pure virtual plus no data members. Abstract class can have pure virtual normal function data members. Interface has only pure virtual functions. What is timing problem? There's an inheritance problem because the base copy is contained twice in all the derived classes, and therefore we use virtual inheritance so that only one copy is kept. Composition versus inheritance. Composition is loose binding because of this, but loose coupling, but inheritance is tight coupling. What is upcasting? Whenever you move your derived class object to the base, it is always safe, but downcasting is not safe. So you should use dynamic cast for that. What is the difference between public, protected, and private? Private is accessible only inside the class with getters and setters. Protected is accessible with the class and the derived class, but public is accessible from anywhere by creation of an object. What is the difference between early binding, late binding? Early binding is static. It is during compilation, and late binding is during runtime, during execution. Okay, guys, next. Memory is very high level, high value topic because system, they love it. When a C++ program runs, the memory is allocated into, this is very important. So you have stack, you have free memory area, you have stack, you have heap, you have DSA segment, you have data segment, you have text or code segment. This is the memory layout, don't forget this. You have low address. So your stack always grown downwards, but your heap always grows upwards. Stack is limited, heap is unlimited. There's BSS segment where uninitialized static variables, global variables are kept. Data segment where they have initialized, they are kept. Text and code segment where text and code is kept. And low address, which is the address of your. So this is low to high address of your memory layout. Text segment, starting from that, or the code segment. Your compiled machine instructions, they are kept here. Your executable code is kept here. The instruction for foo lives here. Characteristic: it is read only, shared among processes wherever possible, exists through program lifetime. Can we modify the code segment at runtime? No, because this is read only, so you cannot modify it. Data segment, stored initialized global and static variables. So once they are given a value, they are stored in the data segment. They exist for the entire program lifetime. DSS is block started by symbol. Block started by symbol. It stores the uninitialized global and static variables. Executable size becomes smaller because zero initialized data does not need to be stored in the executable. Heap, dynamic memory allocation, allocated manually or with this malloc. Program controls lifetime, larger than stack, slower than stack, can fragment. Stack, function parameters and all of that goes onto stack. Function parameters, local variables, return addresses, saved registers. Automatic allocation, very fast, limited size. Stack frame. Every function calls creates a stack frame which has the function parameters, local variables, return address, save registers. Stack is faster because it requires finding free block, managing metadata, and synchronization. Just moves the stack pointer very cheap. Heap allocation requires new and malloc, which finds the free block, manages metadata synchronization. So just moves the stack pointer. Stack allocation just moves the stack pointer, which is very cheap. Dangling pointer that points to an invalid memory. Undefined behavior. Memory leak, memory allocated but never freed. Function exists, pointer lost, memory still allocated. While pointer, uninitialized pointer contains garbage. Null pointer, safe invalid pointer. Always initialize pointer this way. Heap fragmentation, many small holes. Large allocation may fail if total memory exists. Call fragmentation. What happens during new? Allocate memory from heap, call constructor, return pointer. What happens during delete? Call destructor, release memory. Malloc versus new. Malloc, it's a C function. In no constructor is called returns void star. But new, it calls typed safe, calls a constructor C++ operator. Free versus delete, no destructor call, but in delete there is a destructor call similar to constructor call in new versus malloc. Stack overflow, infinite recursion. Every call creates a stack frame. Eventually, stack fills and crash. Memory alignment. Interview sometimes asks this. CPU prefers aligned memory for padding. C padding. Size. This often becomes 85, requires alignment. Very important, C++ resource acquisition is initialization. Resources tied to the object lifetime. There will be no leaks, automatic cleanup. Smart pointer, modern C++ memory management like unique pointer, shared pointer. Unique pointer has a single owner, shared pointer has multiple owner. There are reference counting, but unique pointer cannot be copied. Weak pointer, no owning disturbance. So in memory layout, I want to clarify that the stack grows upward or downward, and heap grows upward or downward. The stack grows downward. On the modern architecture, the stack grows from higher memory addresses to lower memory addresses. Every function call pushes a new stack at a lower address. Heap grows upward. The heap typically grows from lower address towards higher address, complete memory. So stack grows downward. There is some lot of free space for the heap to grow. Then there is DSA segment, block started by symbol. There is data segment. There's text and code segment, and then there is low address. To maximize available memory, both standardize opposite ends. The process can use as much memory as possible before the two regions collide. Yes, because that can be stack overflow. Okay, so now we have covered all the OOPS fundamentals. We have covered memory layout. Now let's move on to all the C and C++ basics. So let's first start with C++, all the basics of C++. Like I don't want to learn STL and all that from the like system engineer and all of that point of view. I want to understand C++. Yeah, first give me concepts, and in the next prompt I will ask you for top interview questions. This is asked. So your source code is pre-processed. All the macros includes they are expanded. Then it is compiled into assembly code. Then assembler converts it into object file, which is then linked with a linker to executable. Preprocessor handles, produces expanded source, converts into assembly to machine code, produces test.o, linker combines the object files and libraries, produces executable, removes the external symbols and combines object files into a final executable. Stack versus heap, we already covered this. References is an alias. Why references? It avoids copying. References versus pointer. References, they cannot be null, they cannot be seated. Pointer can be null, can point elsewhere. Constant, very important, they cannot modify. Constant pointer can move the pointer but cannot modify value through the pointer. Pointer constant, okay. Const variable, you cannot modify it. Const pointer, it that relationship, that pointing relationship is constant. You can move the pointer, but you cannot modify the value through the pointer. Pointer constant. So this is in star, that is, you cannot modify that. But if the pointer is constant, you cannot move the pointer, can modify the value. Cannot modify either interviews like this. Pass by reference, pass by value, copy is created, copy is not created. Const reference, no copy cannot modify, best practice. Static. Initialize once remains value across calls. Static class member shared across all objects. Even one copy exists. Static function belongs to same class, no object created. Cannot access non-static members. Static functions are another favorite interview topic because it's very different from normal functions. What does static mean? The function belongs to the class itself. It is tied to the class, not to an individual object. Normal member function. This calls. Internally, the compiler converts it roughly to this. A hidden parameter called this is passed. Static member function calls this. No object exists. No this pointer exists. Internally, it behaves like this. Then this. Why can't static functions access non-static members? Compiler error, because salary belongs to an object, but this has no object. Which salary should it print? There is no this pointer to tell the function which this points to. Static function can access static variables. Works perfectly. Why? Because this belongs to the class. There is only one copy, no object lookup needed. There is no this pointer to that, can access only static members, is commonly used for utility functions. Inline functions, compile may replace call with actual code, reduces call overhead. Namespaces avoid name collisions. Constructors called during object creation. Default constructor, parameterized constructor, copy constructor, move constructor with R value. Destructor, RIA depends on this. Copy constructor, shallow copy, bitwise copy, dangerous for heap resources. Deep copy, both point to same memory, bad. Deep copy allocates new memory. Move constructor, huge modern C++ topic. Instead of copying, ownership is transferred, resource stolen much faster. L value, R value. L value has a name. X is a L value. R value is temporary. Move semantics exploit this. Rule of three: if a class manages resources and defines destructor, then it usually needs all the three. Destructor, copy constructor, copy assignment. Rule of five: destructor, copy constructor, copy assignment, move constructor, move assignment. Resource acquisition is initialization. Just try to that. Smart pointer, unique pointer, make unique. Shared, reference counted. Weak pointer, no non-owning observer, break circular references. We can move to C now. Or first, let's cover the top 20 interview questions related to C++ only. What is difference between C and C++? C is a procedural language. C++ supports C is not an object-oriented language. C is a procedural programming language. What is procedural programming? Programs are organized around functions, data structures, procedures. Why C is not OOP does not support anything. Struct. Okay. C struct versus class. C is a procedural language. It supports OOPS, template, RAIA, exception handling, STL, smart. C++ is essentially C plus many higher level instructions. What is difference between pointer and reference? Pointer and reference. So pointer can be null, can be reassigned, can require dereferencing. The references, they act as an alias. They cannot be null. They cannot be reseated, and they have to be initialized at the same time. What is the difference between stack and heap? Stack is fast. There's automatic cleanup when it goes out of scope. There's limited size, but heap is much larger, slower, obviously, because then there are system level commands like malloc, new. They are overhead of that, and manual management. RAII. Resource lifetime is tied to the object lifetime. When object dies, the resource is automatically released. This is one of the most important, the smart pointers. Mutex. What is copy constructor? When creating an object from another copy, what is shallow copy? Default copy behavior. They point to the same memory, they have the same resource, and that is changeless. They have independent resources. Rule of three. If a resource and defines constructor, they generally need copy constructor and copy assignment. But they also sometimes need copy constructor, copy assignment, copy move constructor, move assignment. What is move constructor? It transfers the ownership with R value instead of copying ownership is move, which is much faster. What is move? Important trick. Many people move does not move anything. It simply casts an object into an R value reference. Actual movement happens inside a move constructor or move assignment operator. What is difference between L value and R value? L value has an identity, X is an L value. R value is temporary. Move semantics are based on R values. What is const correctness? It guarantees that there is no copy. Function cannot modify the input. What is difference between this and this? So here, your value the pointer points to cannot be changed, but here your pointer cannot point to something else. So your pointer is movable here, data is immutable here, but here your pointer is fixed, but the data is mutable. What happens when new is called? It allocates memory from heap, calls the constructor, and then it creates a pointer, returns a pointer, which is a type pointer. What happens when delete is called? It calls destructor, deletes memory. Malloc versus new. Malloc is a C function. It returns void star. It doesn't call the constructor. But new is a C++ operator. It calls the constructor. It also returns a type pointer. Free versus delete. Free is no destructor. Delete calls destructor. Why use smart pointer for RAIA? Because it has its word manual memory management, one owner, multiple owners, observer. There's no leak, exception safety, avoid automatic cleanup. What is name mangling? Compiler imports parameter information into simple names called name mangling. Need for function overloading. Why is C are sometimes wrapped with externcy to disable mangling? Why can't constructors? Because object is not fully constructed. Proper cleanup. VTable, VPTR. Okay. Next, we can move on to C. Also, you didn't cover struct versus class and all of this. So I am thinking that we'll cover it later, like once we cover C. So first, we are going to cover all the basics of C, what is different in C than C++, and then we'll also cover the interview questions later. But here only cover the main important concepts of C and also like what information can be useful in some debugging type of questions in C, which we'll do also later once. Linux kernel is written in C. Network stack is mostly C. Device drivers are mostly written in C. Routers and switches are a lot of C and C++. C is procedural. C++ is multi-paradigm. C, everything is in revolves around functions, structures, memory. There is no class, inheritance, polymorphism, templates. There is no RAII. Struct, very important in C. There is struct. Notice struct must be written. In C++, there is struct. No need to write struct. Struct versus class, extremely important common interview question. C++, you have this. Only difference, struct default access is public, class default access is private, otherwise almost identical. Pointer fundamentals, most important. So you have x is 10 in this memory. X is 10. P is the address of x. D reference star P gives 10. Interviews love pointer questions. Pointer arithmetic. P plus 1 points to 20. Does not move by 1 byte. It moves by size of int, which is 4 bytes. Array and pointers, important relationship. Array names usually decays to and 0, which is also a typically a pointer. Pass by value. C supports only pass by value. Important concept, very, very important concept. This is very, very important concept. C supports only pass by value, original value unchanged. Okay. To modify this, I have one doubt. So doesn't C support pass by reference? Why does it not support pass by reference? And if that in that case, like how is how do we pass by reference a variable to in C versus in C++? C does not suppose pass by reference. Every function parameter is passed by value. Because a copy is made, only the copy changes. Then how do we modify the original variable in C? By passing its address. So we increment this. Is this pass by reference? Technically, no, this is still pass by value. You are using this, which is a point copy of the pointer. The pointer itself is passed by value. Visualize it. C++ reference. C++ introduced references. C does not support pass by reference. C supports only pass by value. Reference like behavior is achieved by passing pointers. C++ introduced reference, which is an alias for existing variables and allows true pass by reference syntax without explicit pointer manipulation. Void pointer is a generic pointer, can point to anything. Need cast before dereference. Dynamic memory allocation, calloc, malloc, reloc, free. Malloc, memory is allocated, not initialized, contains garbage. Calloc, memory is initialized and allocated. Realloc, memory is resized. Free, release the memory. Dangling pointer is danger pointer, refers to freed memory. Best practices, make it null. Wild pointer, never initialize, contains garbage, which is also undefined behavior. Null pointer, known invalid address, which is safe. Extremely important C topic. This int star int command fp. Assignment fp is at. Call fp23 or this. Used heavily callback event systems. Type def. Simplifies declaration. Static variable, very common, three meanings. Local static retains value. File static, visible only within current file. Static function. Cannot modify x, volatile. Does not. Memory alignment, bit manipulation. Okay, I know this already a lot. Clear bit, toggle, I know. Header file, preprocessor for compiling and creating executive. Can we do this? G++ type test.c minus o test. Yes, you can do this, and it usually compiles successfully. However, there's an important detail. What happens, even though the file extension is C, you are invoking a C++ compiler driver, so the file may be treated as C++ code rather than pure C code. Behavior can depend on compiler configuration, but generally this compiles and links with C++ libraries. The command is gcc for C++ G++. Suppose you have this. This is valid in C. Actually, in C, works without explicit cast with this. GCC scheme does not automatically. Yeah, you're fine. Okay. I'm almost done with this topic also. And done with this topic also. I'm going to now revise design principles, design patterns. Clinic commands I'm already aware of. Sorry, guys. Yeah. Struct and class, they are almost identical. The only difference is access modifier instruct default is private and class it is public. Both have data members, member function, constructor, destructor, inheritance. No. Okay, yes. Virtual function template, static, and all of this. The real difference. Default access modifier, struct is equivalent to this. Class is equivalent to this. Default inheritance visibility, struct is equivalent to this. Because this and this is this. Memory layout, there's no difference, but usually same memory layout constructors. By convention, we use struct for simple data objects, SDO, simple data objects, or mostly public data. But why do we need class for encapsulation, abstraction, business logic, data hiding? C versus C++ structs, this is where things get interesting. C struct, you cannot have, C structs are just data containers. C++ structs can have full OOP operation. So what should I do? Simple data, what is data type? They're almost identical. The only language difference is that struct has public and private, while the class is private and there's so inheritance. Default is going to change, and then there is also in C, if you write struct, it doesn't support OOP, so you cannot, they're just data containers. But in C++, they support all the OOPs principles, and in C, if you create an object of a struct, you also have to mention the struct keyword, but in C++ can't. Data transfer object. Data transfer object is simply an object whose primary purpose is to carry data from one place to another without containing business logic. So it's this data transfer object. Yeah, fine. Versus business object. Yeah. So it is an object. Data transfer object is an object used to transfer data between different layers and services. It typically contains only data fields, literally no business logic. TTOs are often implemented as structs in C++ because primarily they act as data containers. Okay, it's 10. Okay, it is 11. Okay, it is 20. Okay. Oh, it's one pointer, uninitialized undefined behavior. Okay. Oh, it's dangling pointer. Okay. Double free undefined behavior. Okay. Okay. There's memory leak because manual memory management is required because it was on heap. Okay. It is 5 and 6. Okay. Post increment, pre increment. Post increment. 6. Pre increment. 20. 8. 6. Null. Null character. C. Character array. Malloc versus calloc. Not only allocate, not initialize. Initialize and allocate. Static, yes. Buffer overflow. 8 because there is padding here. Null character. Dereference first then move. Okay, guys. Now I'm going to revise design principles and design patterns. I will be back in some time, guys. Bye.